Okay, guys, so we're starting with factoring when a equals 1 and when a does not equal 1. So that's trinomials. We're working on trinomials. That means 3 terms. So the first, most important thing, and I don't know why we always forget this, GCF. When you are looking at factoring problems, there's so many different ways to factor, and you get bamboozled or all spiraled up and don't know which one to use. First thing first, on your list of priorities, always check GCF first. That's greatest common factor. So we're always looking for a greatest common factor first. There may not be one, but it's a great place to start on every quadratic or every factorable problem. So looking at these 6 problems, we're going to look for a GCF. So we're looking for what number will go into, multiply into. So we're doing the opposite of the distributive property. So kind of like we did opposite of box method earlier, we're undoing a distribution. So if we're looking at number 1, we're looking at 16 and 4. What number do they both have in common? So 16 is divisible by 4. So we know we can take out a 4. There's a P in both. So if you look, and it can be 10 terms, if you know there's a P all the way down, look for the lowest exponent, and that's the number you can take out. So it's going to be P to the third. Then your leftovers go on the inside. So 4 times what gives me 16? 4. And I have P to the third, which leaves me with 1P left over. 4P to the third is what we have in the back of our polynomial here. So we're going to put plus 1, because you have to have a space holder there, because again, this is going to multiply back together to give us this. And you could check your work if you wanted. So at that rate, 4P cubed times 4P is 16P to the fourth. And 4P cubed times 1 is going to be 4P cubed, which is the problem we started with. So that means you factored out the GCF correctly and checked it. If that does not, your brain doesn't think like that. I've taught in Math 1 a hockey stick method is what I call it. So I'm going to take my problem here, and 9 and 36. Now, some of you know 9 is your biggest number, but let's pretend like you just saw 3, because there's a 3, there's a 6, there's a 9. So we'll pull out a 3. And if I take out a 3, 3 times what gives me 9? That'd be 3. There's an X still there. And 3 times what gives you 36? 3 times 12. Now, you're going to check inside your hockey stick and see, first things first is a number. There's a number and a number left. Are they in their most prime form? Like there's nothing else that they could have in common. As we see here, 3 and 12 have a 3 in common. So we're going to pull out another 3, which 3 times 1 gives me 3. So X is all that's left. And then 3 times 4 gives me 12. Now, X and 4 have nothing in common because one's a variable and one's a constant. So we know we're done. Now, here on the outside, you're going to multiply those together, and that's going to give you 9. And then these are our leftovers that go inside the parentheses. So 9x plus 4. If you distribute it, 9 times x is 9x, and then 9 times 4 is 36. So that's exactly where you came from. So hockey stick method is a way to go slowly through it. So even the 16 and 4p, if I took that 16p to the fourth plus 4p to the third and did that hockey stick method. So everybody likes to use 2 first. So if I took a 2 out here, I end up with 8p to the fourth plus 2p to the third. So 8 and 2 obviously have more in common. It's another 2, which leaves me with 4p to the fourth plus p to the third. Well, now I see that the numbers are taken care of. So I have a 4 and a 1. That's the best I can do. I have p to the fourth and p to the third. You can pull out 1p at a time if you want. It just takes a lot longer. Again, it just depends on how your brain works. So then this is going to be p to the third. This will be p squared. So I still have p, so I'm going to pull out another p. So I'm taking away 1p, 4p squared plus p. Still got some p's left, so I'm taking another p. Gives me 4p. There's nothing there, so we're going to put a 1 because p times 1. Because remember, this leftover has to multiply by this to get what you started with. Then you're going to work down your side. So 2 times 2 is 4 times p is 4p times p is 4p squared times p is 4p cubed, which we already knew here. But that's another way to break it down if your mind doesn't necessarily grab a GCF on its own very quickly. So it's just a backup option if you should choose to use it. Now, 63 and 45, B. They don't have a B in common. 63, the first number I think of is 3. So let's start there. So let's pull out a 3, and that'll give me 21 plus 15B, which 21 and 15 still have another 3 in common, right? So I can pull out another 3. So I'm basically using my hockey stick method, but I'm just not writing it the same. So that's going to give me 7 plus 5B. 7 and 5 are prime, so nothing else. So 3 times 3 is 9. So I can pull out a 9. And my inside would be 7 plus 5B. So again, practicing with GCF. It's a slow and steady process, but always check for GCF. Like I said, there might not always be there one, but if there is, it will make your life a lot simpler to get it as small as possible to get to start factoring. Now, this trinomial, we want to check it for a GCF first. So 28, 8, and 36. So we can do this hockey stick method, or you can do it if you see it in the beginning. But another call out. In the front here, this number is negative. That's no dice. You do not want the front number to be negative. You want A to be a positive 1 if you can, or a positive number in its smallest form, because then you can multiply and do all the fun things. So we are going to figure out, we're going to pull out a negative first, for sure, because we want this to be positive. We have an 8 and 36 and a 28. I'm going to go with 4, I think. Yep. I'm going to pull out a 4 first. So 4 times 7 is 28, and it's a negative 4, so that's a positive 7. X squared. Negative 4 times a positive 2 gives me that 8, and then we got to have our X. And negative 4 times a positive 9, gives me a negative 36. 7, 2, and 9, there isn't anything that they would all go into that will make it better. So for right now, if you're just factoring the GCF, you can stop here. Now, the trick is, after today's lesson, you will never stop here. We will continue to factor, and I'll come back to this screen in a minute. So looking at another trinomial, so we're factoring out a GCF. So negative 8, 24, and 12. And then we got a lot of X's. The farthest one down, when it's in standard form, 7, 6, 5, we know we can pull out 5. So you can put that on the first hockey stick, or you can put it at the bottom. Either way, we have a 12, a 24, and a negative 8. Remember that negative is a problem. So we're going to pull out a negative something. I'm going to go negative 4 again. And that's going to give me a 2x to the 7. Negative 4 times a negative will give me a positive. So negative 4 times 6 will give me that 24. Negative 4 times what will give me a positive 12. At any time during the videos, do you want to pause it and try this yourself and then come back and check it? I highly recommend it. But otherwise, just keep on going. So negative 4 plus, it's going to actually be a negative 3, because negative and negative will give us that positive x to the 5th. Now I have 2, 6, and 3. So with 2, 6, and 3, nothing will come out of all of those, because 3 and 6, you could pull out a 3, but 2 doesn't work to be able to take out a 3. Like, you cannot divide 2 by 3. And then 2 and 6, you could pull out a 2, but the 3 at the end makes it a problem. So now we're looking at our x's, and again, like I said, so 7, 6, 5, the lowest exponent, we can pull that guy out. So what's going to be in our parentheses is 2x. There was 7, so I took out 5. There's 2 more. Minus 6x. There was 6, so we took out 5. It means there's 1 left. Minus 3, there was 5. We took out 5, so there's none left. So the inside of our parentheses now is a trinomial, quadratic, which, like I said, for right now is perfectly fine as this, with the negative 4x to the 5th on the outside. But after today's lesson, we are going to push this a little further and go ahead and factor that. All right, so we got 2 more. Pause the video right now and see if you can do number 11 and number 12. You're just factoring out the GCF. Looking at number 11, it's out of order. It's not in standard form. So it's constant 2, 3 instead of in standard form. That'd be a negative 20, and I'm going to change it to an x cubed minus 35x squared plus a positive 20. And this matters because, remember, we want a, so that first term, to be positive if we can. So in this case, we're definitely going to pull out a negative. We got 20, 20, and 35. I'm going with 5. There's not an x at the back end. So we can't pull out an x out of all three because we have a constant. So there's not an x in all three terms. So that is not, it cannot be pulled out as a GCF. So if I'm going to end up with a positive 4x cubed minus 7, it's going to be a plus 7 actually because we want it to be a negative. Negative 5 times positive 7 is negative 35 x squared. And then negative 5, and there I did it again. I got excited. Times a negative will give me a positive. So we're going to put a negative 4. So it's negative 5 times 4 gives me a negative 20. Negative 5 times 7 gives me a negative 35. And negative 5 times a negative 4 gives me a positive 20. So then our GCF is a negative 5. And then we got 4x cubed plus 7x squared minus 4. So for now, we're good. Hopefully you tried number 12. It is in descending order, 6, 3, 2. So you're perfect. So we're going to pull out about a number that goes into 9, 63, and 90. So obviously 3 is a good one, but I also wonder if 9 is a good one. You can check 63 and divide it by 9. Or you can work through your entire, hockey stick method and slowly get down there. So I'm going to start with 9 because I'm feeling pretty good about that. So I have x to the 6th minus 9 times 7 is 63. And then minus 10x squared. 1, 7, and 10 is the smallest number, but they are all pretty prime. None of them have a common factor. Then you're looking at your x's again, the smallest exponent, so x squared. So that's going to give me x to the 4th because I had 6 and I lost 2 minus 7x. I had 3, I lost 2, so I'm left with 1 minus 10. Had 2, lost 2, so we're done. So it's 9x squared, x to the 4th, minus 7x, minus 10. So now you've taken out that GCF again fully. All right, guys, that's GCF. Make sure you know how to do GCF. Don't forget about it either. We always forget. It's your number one go-to for factoring.